interview handbook.
Yes, yeah.
The In that I having doubts, ma'am.
Yeah, you can present your screen and you can
Okay,
ask.
okay, ma'am.
What?
Ma'am, I'm not able to share my screen
Right.
as I'm not used to.
Yes. Now you try.
Yes, ma'am. Ma'am, my screen is visible to you.
Yes.
Okay, ma'am. Ma'am,
Mm-hmm.
as you can see on the screen on the question on second, difference
Mm-hmm.
between UVM component.
Mm-hmm.
The explanation is given in this question and the explanation given in this question both are the same. And the explanation of the
Mm-hmm.
both the question is about UVM transaction and UVS sequence item. The
Okay.
explanation of the second question is not here written here, and the
Mm-hmm.
UVM transaction and UVM sequence item is both written here. So I want
Mm-hmm.
to know about UVM object and component
Okay.
difference.
Okay. So if you would have gone through the previous sessions, you will be finding the difference between the UVM object and UVM component. That is actually UVM component are nothing but which will be inside the hierarchy. So whatever the driver, monitor, then the sequencer, then whatever other components, the UVM test and the scoreboard, everything, these all are the components. So which are the components? No, those things we have to register in the factory through the component macros. So the UVM sequence and UVM transaction, these two come under the UVM object. So these are not inside the hierarchy, they are outside the hierarchy, and they are not, the UVM component is nothing but will be there for the entire simulation. From the start of the simulation to the end of the simulation, these will be there, the UVM component. But when it comes to UVM sequence item, they are not so. They are there for the limited simulation time is what there as a UVM library. Okay, in the UVM library, it is defined this way. This is designed this way. These two things, UVM component and UVM object. So the UVM object, only the sequence and transaction class. So these two, if you see the previous sessions also in the coding part, we have registered those things using the UVM object macro, basically. Once again, you go through related to this component and object. Uh, I have explained. If there is something you haven't understood, again, you can go through the session. Okay.
Okay, ma'am. Okay.
Yeah.
And
What is the other query?
yes, yes, ma'am. Ma'am, in this line,
Mm-hmm.
uh, I don't understand this line. The create method of wrapper class is used to create object for the UVM object and component, which is
Mm-hmm.
commonly known as factory registration. Can you
Okay.
explain this line?
Okay, basically, as I said, we have a new method, create method. Both do the same thing actually. The create, but if you want to have the flexibility of the UVM factory, then you have to follow the create method, because rather the create method will inside call the new method itself. But using the create method, if you do, the UVM factory will have the track of the different components that you have created. Okay, so that's why we need to prefer the create method. If you see, this also I have explained what is create and new, all that. So basically what here they are trying to say is the create method of the wrapper class is used to create the objects for the UVM object and UVM component class, which is commonly known as factory registration. Actually, this line is not making that sense, but if you really want to understand what is create and new, in our PDF, we have it, I guess. Let me share it with you. So have you gone through the previous session?
Yes, ma'am, but
In that,
want to know.
we have something called create a new, right? If for
Yeah,
any of the things it is not making sense to you, just go through our session, whatever is there, no, that thing instead of
ma'am,
going through this. Okay.
ma'am, actually I gone through that, but not understand the particular things I am asking. That's it.
No, I'm not saying that. Don't
Okay.
ask me. I am telling you that if something is not making sense related to the, like how you have told me, right? Here, this create what it is explaining, I didn't understand it. So, those things don't refer from this answers. Just go through the questions from this, and the answers you can go through the material which we have shared in the recordings. That you can just make a note saying that for create, if someone asks you related to create, you can refer that instead of this, because this is not that appropriate. You, even I feel and you are feeling, right? This interview handbook, usually you refer for the questions, not for the solutions. Solutions you refer our material. Okay.
Okay.
Mm. So I will present the screen.
Ma'am, I have more doubts.
Yeah, that's okay. I will clear it once after this. Okay. So related to the create, here we have it. So here it's all about the factory registration for the, this is the function new constructor defaults, all these are there for the different component and the object. This is all about the
Ma'am, your
factory.
screen is not visible. I have to stop my sharing.
Okay, stop your sharing. What about others? Are you able to see the screen?
Yes, ma'am, we are able to see.
Okay. Which screen you are able to see, the UVM factory, the PDF thing which I am telling, or
Yes, ma'am, what you are
okay,
sharing.
okay. So maybe you can stop sharing and you can go to the home screen and you can refer.
Yes, I'm showing your screen.
Okay, yeah. So here we have register component registration and the object registration, all this, right? After this, we have created like this, the create. The create method takes two arguments. One is the name string and the other is the pointer to the UVM component. And the values of these arguments are used to create an entry in the linked list. Basically, in the UVM factory, there is something called lookup table where it will, whatever things we have registered, right? Though all those things will be there in the UVM factory. So if we use the create method only, we will be able to use the UVM factory, whatever benefits it's provided by the UVM factory, those things we can use. That's why we need to use the create method. But the create method will be pointing to the new method itself. Inside, if you see the source code of the create method, it will be the same. But if we use create, the whatever components we are registering in the factory, only for those components we can use the create method. So how do we use the create method is, for example, this is our master agent and I am creating the object of this. So whatever they're trying to say is to create the wrapper classes. So this is nothing but the master agent wrapper class, right? So there we have one object. So you have to take this object and then whatever from the its basic thing, means from which we have created its instance, that thing you have to write, and then you have to write, this is a syntax like this, the scope resolution type ID, and then create the same object you have to give it, and you have to give it as this. For all these things, for all the create method, this is going to be the syntax. If you use new also, it will not give us any error, but you cannot use the UVM factory benefits. That's why we use the create method. If anyone asks you what is the difference between create and new, this is how you can explain. Okay.
Okay, ma'am, but
Yeah.
you use the language wrapper
Mm-hmm.
class and the class is different.
Mm-hmm.
Wrapper,
Wrapper
wrapper.
class is nothing but for example, the agent is there. So agent has driver, sequencer, and monitor. So for all this, agent is nothing but a wrapper class, because it has wraps under, it has some hierarchy down it, and there are some components inside that. So you can just call it as any way. That's not a problem. Here you have to understand what is the significance of create and new basically. That should be enough. Okay.
Okay, ma'am. And ma'am, in this thing that factory you used
Mhm.
here, in that
Mhm.
one mechanism here, override,
Yeah,
uh,
yeah.
that I can't understand. Can you
We
please?
haven't discussed so far that factory overriding. It
Okay,
is
ma'am.
yet to be discussed.
Okay, ma'am. I am having doubt in APB, ma'am.
Okay, okay.
Can I ask, ma'am?
Yes, yes.
Yes, sir. Wait.
Two members, they have come and they couldn't join and they left, I guess.
Yes, ma'am. Ma'am, the video you shared in that explanation of APB that written that
Mm-hmm.
APB is used as a interrupt controller
Mm-hmm. Mm-hmm.
as a general purpose register. So
Mm-hmm.
I want to know that how APB is working as an interrupt controller as interrupt is coming from outside. So how it is used? Can you
Actually,
explain?
that recording was not made by me, some other, but maybe APB protocol there, see, it all depends on the requirement, right? So the APB protocol will be working as an interrupt controller in the sense, for example, you have different, for example, a subsystem is there. There you are using your APP interface. For example, you are trying to transfer the data from one of the IP to I2C IP to some of the VIP. You are sending the data. So you have to send the data. For that, we need to do some configurations. So to do some configurations, we are using suppose the APP interface. So how the configuration means for all the APB I2C interface, we will be having some the I2C, we will be having different configurations, right? We have to set the start bit, we have to set some stop bit, everything. So for all those, we can use the APB interface to do the configuration. So the APB interface, in that you can give some address, whatever addresses are there, no, those will be fetched in the P address of the APB interface, and rest all whatever you are configuring, those will be as a P write data. So for example, in that there is something called or some DMA or anything, if there is some interrupt mechanism that you are trying to control, so then the APB controller there will also do the configurations related to that interrupt controller. So all those things also we can write into those registers of the interrupt register. So based on the requirement, your APB protocol will work, right? So that's how in maybe in that knowledge there could be something like APB is working as an interrupt controller. So first of all, to the one someone has asked a question also in the group today morning, like why do we have different like for write data, read data? So the protocol is designed like that, but based on your application in the industry or any of the project, your protocol you have to find out which protocol is suitable. If it is suitable, then only you will choose that protocol and you will use it. That's it. So no protocol will be acting like this or that. Any protocol will be acting that particular agent or whichever interface which you are using. So if I have APB interface, I will have to know what is the APB protocol working. So those things we will learn here and you will apply it in an industry point of view. So here you have to focus on what are the different ways of communication is allowed in the APB. So what is the different phases in APB and what is the data transfer, how the data transfer is happening, what are the necessary signals we need to understand to check the data transfer. All these things should be your main focus. So that video, in what context they have spoke, I will refer it once again. And if I feel that this explanation what I have given to you is not enough, then I will definitely tell it. in the next session or somewhere sometime.
Okay, ma'am.
But
Thank you.
in my knowledge, that should be the case.
Okay.
Because that's how even in any industry it works in the real-time project. Okay, then are you done with all your queries or anything?
Yes, ma'am, I can.
Okay.
Tomorrow
What
I
about
will get new
okay.
queries.
Okay, what about others? Have any queries so far? Okay, so let us discuss how much you have understood so far. Like, what are the I want to understand why do we prefer UVM methodology over all other system Verilog, Verilog, test bench? What is the added advantage of choosing the UVM methodology?
It supports constraint random verification
Mm-hmm.
and it features the layered approach
Mm-hmm.
using sequences
Okay.
and reusability of the
Yeah,
code.
this is the main point. The first point should be the reusability because the main reason everyone is shifting to adopt the UVM is because of its reusability. We can do the plug and play using UVM, all this. So all the points which you have told are sure they are right. But this is the main point you shouldn't forget to mention. That's why I'm just telling you. But whatever you have mentioned, everything is right. Okay. Yeah, go ahead.
And it has a standardized execution phase.
Yeah, correct. And
Mm.
Hello.
yes.
Ma'am, UVM uses as a set of rules and approaches for verification that allows different teams to collaborate more efficiently and understand each other's codes.
Okay.
Means this helps to com help to mean com in communication across the teams between RTL design and verification teams.
Okay. Sorry, can you please repeat what you are trying to say?
Why we use UVM?
Mm-hmm.
The, there is a point that UVM has a set of rules and approaches for a verification that
Yeah.
allows different teams to collaborate with each other, the design teams and verification teams and architecture teams.
Okay. You mean to say there is a proper, as a standard methodology is there, it is easy for us to refer that and
Collaboration
we can
between,
have a common communication between the different teams also is what you mean to say,
yes,
right?
yes, ma'am.
Okay. And anyone else would like to add?
And creating a component using factory here in UVM enables overridden in different environments without
Yeah.
going into the code.
Yeah, without changing the architecture, we can just
Yes.
replace with one of the driver component with the other driver component which you want to override the particular functionality. That also you can do. So, and also for example, this is an agent we have created here. If someone wants to reuse this agent, that also can be possible because of this UVM methodology. So that's why we call it as reusable. So this is also must mandatory point that we have to mention. That is a UVM factory, what now Devika said. The other one is the reusability. Other also some good point you have told me. Something like plug and play and all these things basically. Okay. And we have so many features, right? Like config DB, And what you have told is a layered approach. Like we can use the multiple sequences here to provide the proper stimulus. So all these things are add on in the UVM. And you also told me what is that? We have standardized phases. So someone will ask you like, what are UVM phases? Everyone tell what are UVM phases, like these type of phases. But why do we need UVM phases? Can anyone answer?
To avoid race around condition.
Yes. So basically, to get the synchronization between the different components, if there is something standard way, in this phase this has to be done, this phase this has to be done, there won't be any race around conditions also, and there will be a proper synchronization between the different component flow, right? That's why we have the UVM phases provided by the UVM. Okay, and now which is the time consuming phase and which are the other phases which is zero time consuming phases. So why do we call it as zero time consuming and why do we call this phase as a time consuming?
Runtime phase is the time consuming one,
Okay, yes.
and build time phase and cleanup phase are the ones who doesn't require, like, zero simulation time is required for them.
Yes. So that's why they are called as functions. We have those as functions and
Yes,
run phase
yes.
as a task. Because inside function, you cannot provide anything that gives delay, right? So that's why those are zero time simulation consuming. And the task, you can also all the driver logic, every logic, whatever is there, that is included inside the run phase because there you can provide the delays, everything, right? And there the actual logic of any of the component is there. So that's why all the run phases occur that way. And then how the execution flow of the different phases occur. So the build phase is follows which approach, and
After
connect phase follow, yeah.
connect
Build
phase,
phase uses top bottom approach, whereas
Okay.
cleanup phase uses bottom up approach.
Okay.
Because in build phase we have to create a instance first, so that is the
Mm-hmm.
reason it should be a top bottom approach.
Mm-hmm.
And also it is used to connect between the different test bench components.
Mm-hmm. Mm-hmm. Mm-hmm.
And whereas in clean phase, it is used to extract and compute the expected data from the scoreboard.
Mm-hmm.
So that is the
Correct.
reason the bottom up approach.
Correct, exactly. And you can say instead why build phase use top to down approach because it has to first create the root component. Once the root component is there, then only the lower hierarchy components gets created, right? That's why we can say that you have to mention that root component basically, and rest all you are right. And the run phases in the different components run parallelly. Okay, this also you guys keep that in mind. So this is all about the phases. And actually someone else was telling something, who was that? Other than Devika. Hello? Fine. So what else we have discussed so far? The features of UVM we have discussed. Okay. Now tell me what is the functionality of UVM driver and what is the functionality of UVM monitor?
Driver, it converts the transaction items into pin level activity.
Okay.
And whereas monitor, it
Hmm.
samples the DUT output signals,
Mm-hmm.
collect the information and perform checking.
Mm-hmm. Correct. How does it collect? How the driver drives it to DUT and how monitor collects it through DUT? What is there in between this component driver and the DUT?
interface.
Yes, correct.
Interface.
Yeah. So which interface? Yesterday we have learned about what is an difference between the interface and virtual interface. Why do we need? Why do we adopted the virtual interface here? Can anyone tell me?
Test bench is dynamic,
Mm-hmm.
DUT is
And
static. So we
yeah.
need interface. We'll take handle by using virtual keyword and VAF
Mm.
handle.
Yes.
The
Yes. Correct.
handle communicate.
Okay. Great. So I think we have covered almost. Yeah. What about the TLM? What is TLM? I feel good today. People are responding. I would like to hear from others also.
Ma'am, TLM is a port for
मध्ये
communication.
कसं होतं झालं? नाही मग झूमची सेटिंग घ्यायचं.
TLM is a
Mhm.
port for using transaction level
Mm-hmm.
and used for communications.
Okay.
Yes, between driver and master.
Okay. Okay. So what are the different types of TLM ports, analysis for TLM, whatever, what all we have?
Blocking get port, blocking port and analysis port.
Okay. What is the advantage of using analysis ports over the normal TLM ports and TLM FIFO ports?
We can connect one to many or many to one connections.
Okay. And what else is the advantage?
By using FIFO, we can store some information.
Mm-hmm. Okay. For UVM TLM analysis, I mean to say, what is the advantage? Actually, we haven't discussed that in the writing part, but I have told in that day session, like there is one more advantage for the TLM analysis port.
That is it used for broadcasting purpose?
Yeah, it's used for broadcasting purpose, that's for sure. Other than that, there is one more advantage for TLM analysis ports. It's that it can have a zero connection also. Means we said right in UVM we can do the plug and play in between. Suppose there we have sent from one of the component to the different 3 components or 4 components. Due to some reason we have removed all the 4 components at the receiver side. So even though it has some zero connection also, it will not provide us any error. So if we have any such requirement in dynamically some of the components are getting removed, in those conditions also we can use this analysis ports. That is one of the major advantage by using analysis port. One is the broadcast and the second one is this. Okay. So I think, and can anyone tell me what is the driver sequence handshake? This is very important. And the other thing is the UVM flow. These two if we discuss and then we can start with our today's coding session.
So the handshake between the UVM sequencer and the driver, it
Mhm.
can be done using 2 methods. One is a
Mhm.
get next item or item 10 method, or get input method. So
Okay.
if we want to get a response to the sequencer at the end of the connections, then we will be using get put method.
Mm-hmm.
So here it first creates the sequence items and register in the factory,
Yes.
and then it will ask for it, or it will request for the wait for grant to the sequencer, and wait for the grant from the sequencer to the sequence. Once it returns, it starts randomize the sequence items
Mm-hmm.
and send it to the sequencer using a request call, send request call.
Mm-hmm.
And then the sequencer forward the sequence items to the driver with the help of request FIFO.
Mm-hmm.
So, and then it unblocks the get next item call, and driver receives the sequence item.
Yes, yes.
Once it is done, the sequence gets blocked until the driver responds back. Driver drives the sequence into the DUT using virtual interface. Once it is completed, the item done method is called, or put method if we are using put get
Yes,
input.
yeah, yeah,
So this
yeah.
unblocks the wait for item method from the sequence.
Correct, correct,
So if
correct.
response has to be sent, then the driver
With the
to the
sequence side, what you will have finished item, you said, right?
yes.
Yeah, okay. Then it's right, yeah.
So
So which is the blocking method here? Which is a non-blocking method here? Am I audible?
hello.
Finish item is a blocking method, and
Hmm.
item done will be the non-blocking one.
Correct, correct. Yeah. So Kirti Reddy, you are new to the session, or you are joining even before?
No, I've been there from the first session.
Okay, okay, fine. Okay, great. Everyone have interacted today. I feel good about it. So I am assuming that everyone is on the same track, the one who have not responded also. If not also, that's fine. You just grab this information and get the knowledge of whatever things we have discussed so far. So now today so the APP protocol also we have discussed actually some of the things, like what are the different things we have in the APP protocol, what are the different signals we have, and what are the operations we have, write transfer, retransfer, and what are the necessary signals for the write transfer, what are the necessary with wait states and without wait state. Wait state, all these things also we have discussed. So we will create a skeletal today for the APP UVM test bench, and once it is error free everything, then we can go further for the actual coding of the driver or the monitor based on the knowledge of the APP protocol. Okay, so let me show you this that. Meanwhile, if anyone have any queries, can tell me. We can discuss. Okay, let me present this plan. I haven't spoke anything, that's why I'm not audible. Now am I audible?
Yes, ma'am.
Okay. So I have created the skeletal already. So I will share you the skeletal with all of you. I want you all of you to try at your own end, and you guys whatever doubts you get or you are stuck with some errors, we can discuss. But to have an idea how to work on everything, you should know, right, what all things you need to include in the skeletal. Those things I will explain you today. Before going inside that, let us discuss about the APP protocol design which we have. This is our design. So in order to verify the APP protocol design, APP protocol, we need to have the APP protocol specific design, right? So this is nothing but the design. So
Hello.
every one of you know that in APP protocol, we
Hello.
have different phases, right? Is
Yes.
anyone there or not? Hello?
Hello, you are audible, ma'am.
Am I audible, guys?
Yes, yes.
Yes, ma'am.
Hello?
Yes,
Hello,
ma'am.
you are audible, ma'am.
Yes, ma'am,
I'm
your
unable
voice
to.
is coming. Yes, ma'am, your voice is coming.
Hello?
Yes, ma'am.